Hi, thanks for joining the call. This will be a quick interview round with just one main question. Let me first set the context so we are aligned. Imagine you are designing the backend for an e-commerce system. A user places an order, and you want to process it asynchronously so the user doesn't have to wait for downstream services. How would you approach this?
In that case, I would use Apache Kafka to handle the events.
Kafka already? We haven't even discussed what the system actually needs yet. Help me understand why Kafka feels like the right starting point here.
Kafka is scalable, fault-tolerant, and widely used in production systems. It can handle asynchronous processing.
I agree that Kafka is capable, but capability alone doesn't always justify complexity. In this specific case, do you see any requirement for replaying messages or supporting multiple independent consumers?
No, not immediately. It's mostly a single service consuming the order events.
So we are choosing a distributed event streaming platform for a single consumer with no replay requirement. That's like using a fire hose to water a houseplant.
It still gives us room to scale in the future.
Future-proofing is valuable, but premature over-engineering is expensive. What you really need here is guaranteed delivery, retries in case of failure, and isolation between services.
Yes, that's correct.
In that case, a managed queue like Amazon SQS would solve the problem with far less operational overhead.
But Kafka can still do all of this, even if it's more powerful than required.
It can. The question is whether you want to pay the price for that power when you don't need it. Let's extend the scenario a bit. The payment flow now involves fraud detection, notifications, and audit logging. Each service needs the message in a slightly different way. Some services may only care about certain payment types or risk levels, so they need filtering based on message attributes. Can you think of a system for that?
I would use Kafka topics and let each service consume from them.
That can work, but notice what you're asking Kafka to do here. If you need fine-grained control over routing, acknowledgements, retries, you need to build a lot of logic on top in that case.
Right. I would need to handle them at the application level.
And that is where another kind of message broker fits better, because it natively supports exchange patterns such as direct, topic, and fanout. Can you think of a system designed specifically for that kind of routing?
But Kafka still scales better in high-volume systems.
Absolutely, but we should scale when we have volume, not in case we might. Now let's consider a different case. Imagine a live dashboard showing active user counts, updated in near real time, where latency needs to be extremely low and the data itself does not need to be durable forever.
I would still consider Kafka. It's designed for high throughput and can handle streaming updates efficiently.
Throughput and latency are often confused. Kafka is very good at moving a lot of data. That doesn't automatically mean it's the fastest option for every update.
But Kafka is still quite fast, and it keeps the architecture consistent.
Consistency in architecture is useful, but consistency in requirements matters more. In this case, durability and replay are not priorities. What matters most is speed and simplicity.
So you're saying Kafka would work, but it might be heavier than needed.
Exactly. If disk persistence and consumer offset management are not adding value here, what kind of system would better match this problem?
Something that avoids disk writes and keeps data in memory. An in-memory data store? Like Redis using PubSub or streams?
Right. Kafka hasn't failed, it's just not the right tool for this particular requirement. Now, can you tell me where Kafka really shines?
Kafka really shines when you're dealing with a continuous stream of events at scale, where multiple teams or services need to consume the same data, and you want the ability to go back and reprocess it later for analytics or recovery. I told you, Kafka is clearly the right choice.
Notice how this interview went off track by sticking to one famous solution. This is what interviewers actually look for, not loyalty to a tool, but system reasoning. Kafka is powerful, that is true, but it's not universal. Using Kafka everywhere is like using a cargo ship to deliver a pizza. If you found this useful, like, share, and subscribe for more interview breakdowns.